Okay, today we're going to talk about section 6.6, which is solving absolute inequalities, and this is just part 1. Tomorrow we'll talk about part 2, which is writing absolute inequalities. But first off, we have to review what an absolute value is. Okay, if you start off with recalling that absolute value is just like the idea of distance. If I'm trying to figure out the distance between San Jose and San Francisco, I'm going to be counting in terms of miles, and that value is always going to be positive. You don't ever drive negative miles, you don't fly negative miles, you don't walk negative miles. So it's always going to be a positive number, always positive. So if we look at the absolute value of -4, we can remember that that is always positive, so that has to equal 4. The same goes for 12. Absolute value of 12 is 12. It's always positive. Okay? So we're going to extend that idea to solving when you don't know what the value would be. Okay? In example 1, I have x, the absolute value of x is equal to 5. Okay? And I'm going to draw the analogy that we talked about earlier about distance. What this actually says, and we can rewrite this to be written in terms of distance. The distance between x and 0 is 5. And how would you find distance? Well, how far you are apart from point A to point B, you would just subtract. So I'm going to take x minus 0. Okay? I can write this equation like this, and it means the same thing. Okay? So I'm going to write it out in words so you get used to seeing equations like this. Okay? So what this means is the distance between x and 0 can be 5 units in the positive direction or 5 units in the negative direction. And this will make a lot more sense once we graph this. Okay, I want you to graph this. Here's 0. And x is going to be somewhere, it could be to the right of 0 or to the left of 0. We know that it's going to be 5 steps. Okay, so 5 steps over here would be positive 5. 5 steps to the left would be negative 5. So here we have x could be equal to positive or negative 5. Okay, this would be your solution. 0 is your midpoint, and here's 0, the difference between x and 0, so here's x or here's x. Okay, could be any which way because this is 5 steps and this is 5 steps. Okay, I'm going to go back now and I'm going to show you the two cases written out algebraically. Okay, because sometimes you're going to have to solve it before you graph it. So case 1, what you're going to have, let me show you this. Case 1, we're going to have the positive direction. Case 2 will be the negative direction. And again, we're working with the distance between x and 0. So I'm going to rewrite the equation. The first one stays the same, the positive case. The second one is a negative case, so you have that negative sign out in front. Okay, we're going to solve this one at a time. Okay, let's take case number 1 first. Well, x minus 0 is just x, so that equals 5 right away. Here I have a negative of this value. Okay, so that means that negative of x equals 5. I'm going to divide by -1, divide by -1, so x here equals -5. Okay, and of course when I graphed it, x is positive 5 or x is -5. Okay. Once you get used to the idea of writing it this way, I'm going to show you example number 2. Okay, example number 2 is going to look like absolute value of 2n plus 1 is less than 9. Less than 9. Okay. So again, we're going to break it out to two different cases. Case 1 is the positive case. So I'll just write that, positive case. So I'll have 2n plus 1 is less than 9. And case 2, which is the negative case, will be negative of 2n plus 1 is less than 9. Okay? I'm going to pause here. Why don't you pause here and try to solve these two problems? Okay. You should have gotten subtracting 1, 2n is less than 8, dividing by 2, n would be less than 4 in this case. Okay. On the other side, go ahead and divide by negative 1 right away. So 2n plus 1, remember we're dividing by a negative, so the sign flips, you'll have a negative 9. I'm going to subtract 1 from both sides. 2n is greater than a negative 10, and dividing by 2, n will be greater than negative 5. Okay, I have these two solutions now. I have n is less than 4 and n is greater than negative 5. Let's graph that and see what we have. Okay. Here's 0, here's 4, and say here is negative 5. So n is going to be less than 4 but greater than negative 5. So this is my solution set here. Graphing less than 4 is this way. And I'll use a different pen to show you. Greater than 5 is this way. Okay, so the values, the absolute values will be less than 4, greater than 5. This will be our solution. Okay. Let's take a look at another example. Actually, let's pause here and have you try textbook page 331, number 1 and 2. Try number 1 and 2. Okay. Why don't we try now another example? Call this example number 3. 2k plus 1 is greater than 7. Okay. Again, we're talking about two cases. We're going to break it out into, there's the positive case, so case 1 is a positive case. 2k plus 1 is greater than 7. Or case 2, which is the negative case, negative 2k plus 1 is greater than 7. Okay. Take a second to solve this. I'll use a different pen. If you subtract 1 from both sides, you'll have 2k is greater than 6. Dividing by 2, k will be greater than 3. Here I'm going to divide by 1 on both sides, actually dividing by negative 1. That's very important. 2k plus 1, flip the sign, will be negative 7. Subtracting 1, 2k will be less than negative 8, and dividing by 2, you should have, and I'll move this up, k will be less than negative 4. Okay, so we're going to graph this and see what type of solution we have here. Go ahead and set up a graph. You should have negative 4 here, 0 here, 3 here. So we said k is going to be greater than 3, and k is going to be less than 4. And I think this case, it's going to be an or, because when we graph this, greater than 3 over here, or less than 4. Okay. Now we're going to have you try textbook, page 331, number 4 and 5. Okay. So a really important idea that I want to talk about is going back to what we started with. We said in the beginning, and it was really important, so I'm going to write it really big in red, distance or absolute value can never be negative. Okay, and this is really big. So what do I mean by this? What do you have to look out for? We're going to write a couple equations or a couple inequalities, and I want to let you decide if that makes sense or not. I read this as the distance between x and 0. Can that be -7? Does that make sense? No, it does not. Okay, you cannot do this. Okay, whenever you have this situation, it is no solution. Some people call it a null set, and you can write with a 0 with a line slashed through it. Okay, you might also see absolute value of x minus 2 is less than -9. Here what this is saying is the distance between x and 2 is less than -9. What's a number less than -9? Well, -10, -12. Can absolute value be less than -9? No, it cannot. It can never be negative. It cannot be negative. Okay? So this case does not work either. You get the same problem. You run into the same issues. Okay? I'm going to throw this problem up, and I want you to think about this one really carefully. X plus 3 can this be true? Can this be true? Okay. Let's go back. Is there any number you can plug in here to make this statement true? Absolute value greater than or equal to -4. Okay, I think I'm going to leave this one for you to think about and bring back to class tomorrow. Talk about whether this is something that has a solution or does not have a solution. Okay, and that's it for today. I will see you tomorrow. Bye-bye.